Okay, so in this video we want to look at product rule examples. So recall the product rule tells us that if we take two functions u and v and differentiate them, such as u times v, then we'll get u prime times v plus v times u prime. So if we look at this example here, where we have f of x is equal to x sine x, then u is equal to x, u prime is equal to 1, v is equal to sine x, and v prime is equal to cos x. So then if we put this data into this formula, what we'll find is that the derivative of f is given by 1 times sine x plus x times cos x. And we can just write that a little nicer as sine x plus x cos x. Okay, let's look at another example. Here we have f of x is equal to x squared times e to the 3x plus 1. So here u is x squared, so u prime is equal to 2x, and v is equal to e to the 3x plus 1, so v prime is 3e to the 3x plus 1. And then if we just put this into the product rule formula, we find that f prime of x is x squared times 3e to the 3x plus 1 plus 2x times e to the 3x plus 1. And we can simplify this a little bit and write 3x squared e to the 3x plus 1 plus 2x e to the 3x plus 1. You can go a little further if you want to factorize this, and you can write x e to the 3x plus 1 out the front, and then what remains here is a 3x, and what remains here is a 2. Okay, let's look at our last example. Here we have f of x is equal to tan x. So recall that tan x is sine x over cos x. And we can write this by index laws as sine x times cos x to the negative 1. This is the reciprocal of cos, just 1 over cos. And now we see that u is sine x, so u prime is cos x. We see that v is cos x to the minus 1, and therefore v prime is, well, by the chain rule we take the minus 1 down to the front, we differentiate the inside, which is minus sine x, and then we leave it alone with a minus 2 here. So what we find is that we get sine x times cos x to the minus 2, and that's sine x divided by cos x all squared. And we'll just leave it like that for the moment. You could also write this as tan times sec, but we won't do that yet because it might simplify. So now we put this into the product rule formula, and what we'll have is that f prime of x is equal to u times v prime, so sine x times sine x on cos squared x. So cos squared x is the same as cos x all squared. And then we're going to have u prime times v. So we'll have cos x times cos x to the minus 1. And this is sine squared x on cos squared x plus 1. Now I can make this a common denominator, and I'll have sine squared x plus cos squared x all over cos squared x. And by the Pythagorean identity, we know that sine squared x plus cos squared x is 1. So I have 1 over cos squared x. And this is what we call sec squared x. So let's just note that the step from here to here uses the fact that cos squared x plus sine squared x equals 1. And this is what we call the Pythagorean identity. Okay, so that's easy enough. The basic idea is to just differentiate each function individually and insert it into the formula. It can also be used not just for products but for quotients. So in this case, there's often a quotient rule that's taught, but you can just apply this product rule in the usual way, just with a minor application of the chain rule. If you like the video, please hit the like button and consider subscribing if you want to see more of this content. Okay, thanks guys. I'll see you in the next video.